Okay, so we've talked about how to describe the shape of data distributions and how to describe the spread of data distributions. And so now it's time to spend a little bit of time talking about how to choose the best type of graph for your data. And there are some specific conventions here, but they're fairly straightforward to learn, and they will set you up well for success for presenting your data. So showed you, a couple of graphs already, and as you're setting up experiments, one of the things you need to do is think about how to graph your results. So how do you choose? Where do you start? Well, there's really actually just two simple steps for doing this, so we're going to walk through those. So the first step is to identify your variables. And specifically what you need to do is identify how many variables you have. Do you have just one? Do you have two? Or do you have more than two? And then once you've identified how many you have, you also need to identify what types of variables you are working with. And when thinking about those types, you need to think about them in two ways. So you need to think about type in terms of whether what you're looking at is an explanatory variable or a response variable. So that's one of the types. And then you also need to think about that in terms of whether those variables are numeric, continuous discrete, or categorical, and ordinal or nominal. So for every explanatory variable, figure out is it numeric or categorical, and same thing for your response variables. Are you looking at numeric or categorical response variables? So that's step one. Now, if your answer to the question of how many you have is you just have one variable, then you're dealing in a fairly simple universe. And you're ready to go on to step two, to consult a decision table for the best method for portraying that variable. So with just one variable, it's fairly simple. And I'm going to walk you through the table here just to illustrate that. Right, so if it's numeric and continuous, then the best way to really illustrate it is either with a histogram, as we've seen so far, or a box plot will also work. If that variable is discrete, then it's going to depend on whether it is some kind of count, or whether it's something that is categorical or qualitative. So if it is count data, then that may be something that can be portrayed also with a histogram or a bar plot. If it is something that's categorical or qualitative, so you're counting the number of peas in a pod, something of that nature, then or sorry, not peas in a pod, but apples, oranges, and bananas, then that can be represented with a bar plot. And so in this case, notice these bar plots are not going to have error bars associated with them because you're just reporting the total count for different values. Okay, so that's pretty simple. So however, in most cases, we're interested in the relationship between multiple variables. So you might be in a situation where we're dealing with bivariate data. So for that, I've got three main types of plots for you to consider. And so here's your decision table for these plot types. So the first type are bar plots. And so we've already seen an example of using a bar plot. And bar plots work really well when you have an explanatory variable that is categorical. So with our anorexia data, we've got three different categories of treatments. And when your response variable, your y variable, is something numeric and continuous. So we've got changes in body mass here. So that's pretty straightforward. So we're just going to look briefly then at these other two types to consider. So scatter plots become really useful when you have two variables that are both numeric continuous. So here I've got the participant weight before the trial and the participant weight after the trial shown in a scatter plot. So both of those mass measurements are continuous, and we have each measurement for each participant. And another thing to notice here is that with a scatter plot, it's possible to have at one particular x value multiple different y values, right? There's no kind of dependency between the x and the y. And that contrasts with the third type of plot shown here, a line plot, where a line plot is the most appropriate when the thing on the x-axis is some kind of series. So something that might be a series would be time, right? You can only go forward in time, you can't go back in time. Or it might be concentration. And so there's some kind of, when you draw a line plot, that is indicating that there's some kind of connection between the points in that line plot. So in this plot that Dr. Burke showed you, for the number of surviving flies, right, there were black-eyed flies, red-eyed flies, and white-eyed flies. And so on the x-axis we've got the week of the project, and so it's the same set of black-eyed flies that's measured through time here. So this is showing us a decreasing relationship within those flies. So each x value has just one y value. So I want you to notice one other thing about these other two plot types that I'm showing you here, which is that there's actually 3 variables in each of these plots. So let's take a moment to look at how the third variable is factored in creating those plots, right? So in this scatter plot here, we've got 2 continuous variables, and then we also have different point colors and shapes for the 3 different types of therapy. So we have a categorical explanatory variable that has snuck in here to this plot type. So in some cases, we might see differences across these therapy types that becomes evident in creating a scatter plot. And then same kind of thing down in this plot for fly survival, right? So we have a third categorical variable, eye color, that is included in this plot using different symbol colors and symbol shapes. So these plots can start to get more complex and more rich as we add in additional variables. And that's pretty much it. So just 2 simple steps for figuring out what type of plot is the most appropriate for your data.